Hi, and good evening. So we'll just start this extra session. So this extra session, in this extra session, we'll be covering questions on two-port networks because we couldn't cover that day all the questions. That is one, and of course the second one is probably I felt that out of all the 12 assignments, the two-port network questions are the ones that are a little bit tricky in terms of calculations, and also it would be better if we see that. So we will continue with two-port networks. So two-port networks was part of week number 5. So we already saw a few questions, but anyway, we'll just brush up the concepts briefly and then go ahead with the questions. Can you please tell if my voice is audible and screen is visible?
Yes, sir. Your screen is visible and your voice is audible, sir.
Thanks a lot. Okay, so we saw a few initial questions. These were already covered in the earlier classes, in the earlier class, that is in week 5. So now we will start with some basics of two-port networks and then move ahead with problems. Okay. So just to brush up, two-port network is basically a representation for any electrical subsystem, right? So you have a network of resistors, or let's say you have a network of op-amps or BJTs or whatever may be the network. The idea is that you can represent the entire network, right, based on linearized expressions between input voltage, input current, and output voltage and output current. Okay. So we don't care whatever is there inside this linear network. The idea is, can I simplify? Can I get a matrix equivalent of this entire network that would kind of link my input voltage and current to output voltage and current? That is the premise of doing two-port networks. Okay. So of course, you can have a network that is basically driven by voltage sources, and that's something we see very commonly, right? So you have V1 and V2, which are independent voltage sources, and as a consequence of your network, you will be having some current, right? That is I1 and I2. The magnitude of I1 and I2 are completely dependent on your completely dependent on the network, correct? So that is something we know. And of course, the second part is you have current sources, independent current sources, and V1 and V2 are going to be defined based on your linear network. Okay, so that is the other part. That is something that's based on current sources. Okay. Okay. So we have different parameters as to how we can represent a two-port system. So one of them that you know is, of course, the impedance parameter. That is your Z parameter, correct? So in the Z parameter, you of course fix V1 and V2. Sorry. Yeah. So you of course fix V1 and V2 as our dependent parameters. That is V1 and V2 as dependent parameters. And V1 and V2 are defined by your I1 and I2. Okay. So um, so as you can understand, it would be V1 is equal to Z11 into I1. That is Z11 is the self-impedance or the open circuit input side impedance. Correct. Z11. I1 plus Z12 I2. Okay. So Z12 is a cross-coupling term, that is the transfer impedance, that is between port 1 to port 2, right? So that is the equivalent impedance Z12 into I2, right? And similarly, V2 is equal to Z22 into I2, that is the self-impedance of your output port multiplied by the output current, plus the transfer impedance, that is Z21 into I1. And you know that for a reciprocal system, correct? If it's a reciprocal system, you know that Z12 equal to Z21, or it's vice versa. If Z12 equal to Z21, you call that as a reciprocal system, right? Okay. And how do you find out Z11, Z12, Z21, Z22? So the idea is, from this expression itself, or from this equation itself, you make I2 as 0, you get V1 by I1. You make I1 0, you get V1 by I2. That is why, since your I2 is 0, they have told that Z11 is an open circuit input impedance. Open circuit input impedance refers me, open circuit obviously means I2 equal to 0. Correct? And likewise, you can define what is Z21 and Z22. Okay. Okay. So this is about your impedance parameters or your Z parameters. Correct? Impedance or your Z parameters. So next you come to admittance parameters, which is kind of complementary to your Z parameters, wherein you have dependent sources to be I1 and I2. They are defined by V1, V2. Okay. So here V1 and V2 are a function of I1 and I2. Correct. So from this itself, you can understand that V1, V2 are your dependent variables. Right? And obviously I1, I2 are your independent variables. So over here in admittance parameters, it's the complementary, which means that I1, I2 are going to be dependent variables because I1, I2 will be defined by V1, V2. So I1, I2 are your dependent variables and V1, V2 are your independent variables. Okay. Okay. And likewise, you can find out what is the how to find out y11, y21, y12, and y22 from this expression itself. And because you are going to make the other variable 0, right? That is, if you want y11, you make v2 equal to 0, correct? If you want y12, you make v1 equal to 0. That is why if you are going to tell v2 is 0, that is the voltage is 0, the voltage can be 0 only if there is no drop, right? And when will there be no drop? Only if it's a short circuit. If it's a short circuit, you know that the voltage is going to be 0. Right? If it's a short circuit. That's why you see over here everywhere the definition is short circuit impedance, short circuit output admittance, and so on. Okay. Okay, so I think this is also fine. This is just a recap. So yeah, you just need to know which is a different and independent variable, right? And you then have hybrid parameters or the H parameters, which is kind of a cross coupling, correct? That is V1 and I2 are your dependent variables, correct? So V1, I2 are your dependent variables, and I1 and V2 are your independent variables. Okay. Okay, so H11 is V1 by I1, where V2 is 0, and similarly, the definition is very similar. So you just need to know if it's hybrid parameters, V1 and I2 are related to I1, I2. So V1 and I2 are being related to I1 and V2, right? So thus you need to know this. Okay, V1, I2 are a function of I1 and V2. Okay, and finally, you have your inverse hybrid parameters, G parameters, which is again complementary. So earlier you had V1, I2, right? And now you will be having I1, V2, just the opposite. I1, V2, it's a function of V1 and I2. And of course, I1 and V2 are going to be your dependent variables, and V1 and I2 are going to be your independent variables. Okay. So you understand that two-port network is just basically a representation of your input voltages and currents and output voltages and currents, and you get different parameters based on which two variables you define as the dependent variable and which two variables you define as the independent variable. Okay. Okay. So this was a very brief recap of your two-port networks, right? Yeah. So before we go ahead, um, before we go ahead, we saw that if it's a reciprocal network, then Z12 equal to Z21, correct? Z12 equal to Z21. Yeah, Z12 is Z21 if it's a reciprocal network. Similarly, you will see that Y12 equal to Y21, right? That is the cross terms, right? In your matrix, the diagonal terms would be equal if it's a reciprocal network. It turns out that for hybrid parameters, the cross terms are of course equal in magnitude, but it has a negative sign. That is H12 equal to minus H21 for reciprocal network, right? H12 is equal to minus H21 if it's a reciprocal network. Okay. And yeah, just a second. Okay. So finally we come over to so we have seen V1, V2 as function of I1, I2, then I1, I2 as function of V1, V2. Then you have the cross coupling V1, I2 and I1, V2, right? Finally, we come to transmission parameters, right? Wherein you have input on one side and output on the other side. That is V1, I1 on one side and V2, I2 on other side. That is the input. You will have dependent parameter. The V1 and I1 are dependent on your load. That is V2 and I2. And since the direction of current is taken to be opposite, um, the direction of current is taken to be opposite. Therefore, they have, you notice a sign over here, that's V1, I1, and this is having V2 and minus I2. Okay. So just be wary of this sign. Okay. So V1, I1 is equal to ABCD into V2 minus I2, obviously because of the direction of the current. Okay. And again, you can define what's A, B, C, D based on this definition. And for reciprocity, if it has to be a reciprocal network for reciprocity, you need to have AD minus BC equal to 1. That is your condition for reciprocity. All right. Okay. So with this background, right, that is we have just recapped very briefly what are your ABCD parameters. So with this background, um, let's try to solve some problems. Okay. Okay, so we will move to this question. That is, we'll start from question number 4 of week 5. That is, find G of a two-port network if T is equal to, T means obviously the ABCD parameters. So that is T is equal to 10, 1.5, 2S, 2 and 4. So obviously, we just saw previously, right? In ABCD network, you have A would be V1 by V2. So A is just the voltage ratio, right? A is V1 by V2, whereas B is actually minus V1 by I2. So it's a V by I relation, which means it's going to be in ohms. B would be in ohms And then you have C is equal to I1 by V2. That means it's going to be in the unit mho, MHO or Siemens, correct? And D is again current ratio. So it is dimensionless, no unit. Okay. So seeing the unit also, you can understand its ABCD parameter. So 10 is the voltage ratio, V1 by V2. And you have 1.5 ohms, it's going to be the current or your equivalent resistance, and 2 Siemens is your again I by V relation, and 4 is your current gain, that is I1 by I2. Okay. Okay. So since we know that this is a two-port network, you have let me write using. Okay. So since this sorry, this is the two-port network represented by ABCD parameters, right? Yeah. So you have A is equal to 10, B is equal to 1.5, C is equal to 2S, and D is equal to 4. Correct? Okay, so this is on one side. But let's go to the basic definition of ABCD parameter. So you have V1, I1 is equal to A, B, C, D, right? V2 and minus I2, because minus I2 becomes because of the current direction. Correct? So from this you directly get V1 is equal to AV2 minus BI2, correct? And you also have I1 is equal to CV2 minus DI2, correct? Okay, so this is on one
Sir,
side,
please,
right?
sir, please use a deeper color, sir. It is not properly visible.
Oh, sorry. Okay. Um, let me use red then. Okay. So you have on one end you have okay. So should I rewrite?
No, not required, sir. Not required. Not required, sir. We can manage.
Okay, I'll just rewrite this. Okay, so V1 is equal to A V2 minus BI2, and I1 is equal to C V2 minus BI2. Okay, so this is on one side. On the other end, you have to convert it into G parameters. So we just saw for G parameters that your um, dependent variables are I1, V2, and independent variables are V1, I2. Correct? Yeah, I1, V2, and then V1, I2. So you have I1, V2 equal to G11, G12, G21, G22 into V1, I2. Correct? Yeah. Okay, so now we have to convert, or we have to get a relation for I1 in terms of, so our aim is what? Our aim is basically to get I1 as a function of V1 and I2, right? And we also have to get V2 as a function of V1 and I2. If you are able to get this, you get the answer, correct? Okay, so this is the aim. That is, you're right now you are having this expression and this expression. This is right now with you. So rearrange the terms of this expression such that you get to this. Okay. So the idea is, or the entire question is, rearrange these two equations to this. Okay. Rearrange to get this. That's it. If you do this, you get the answer. Okay. So this is your ABCD. This is your This is your ABCD parameters and this is your G parameters. Okay. So to convert from any parameter to, any equation or any network, what you need to do is just write down and figure out what is your end goal, right? Our end goal over here is to get I1 as an expression of V1, I2 and to get V2 as an expression of V1, I2, which means that in my expression, I want only V1 and I2, right? In my final expression, I want only V1 and I2. If I have anything else, I will try to eliminate it. Okay. Okay. So let's start from here. Yeah. So first of all, you see our final aim is to get I1 V2, right? And over here, the first equation we have is V1. V1 is equal to A V2 minus B I2. I don't want anything to do with V1 right now. So let me take a new slide. Okay. Yeah. So from ABCD parameters, V1 is equal to AV2 minus BI2, right? AV2 minus BI2. So what I will instead do is I will write what is V2, okay? Because I require V2, right? I require V2. So I will write what is V2. So V2 is basically V1 plus BI2 divided by A, right? Okay. So this is one V2 is equal to V1 plus BI2 by A. Correct? So you compare with this particular expression, right? We wanted V2 as a function of V1 and I2. We have got V2 as a function of V1 and I2. V2 is a function of V1 and I2, correct? That is, I can rewrite this expression to be what? V2 is equal to 1 by A V1 plus B by A I2. Okay, this would be one equation. So we have got what is V2, correct? We have got what is V2. Next is I need what is I1, right? So I1 we are having from ABCD parameters CV2 minus DI2, but I want I1 is in terms of V1 and I2. So I have to eliminate what is V2, right? So you have from the ABCD parameters I1 is equal to CV2 minus DI2, correct? Now the aim is eliminate V2, right? So your I1 can be written as C into V2 is V1 plus BI2 by A minus DI2. Okay. So I1 is equal to what? C by A V1, right? Plus CB by A minus D into I2, right? So you see over here, V2 is a function of V1, I2, and I1 is also now a function of V1, I2, correct? So we have successfully converted, right? So what is your G parameter? G parameter is basically I1, V2 as a function of V1, I2, correct? So this is C by A and this is CB by A minus D. And you have this is 1 by A and this is B by A, right? We already know the values for A, B, C, D. Just substitute over here, you will get the answer. Okay. So what is your G? Let me take a new slide. Okay. So your G is C by A, PB by A minus D, 1 by A, and I guess B by A. So what is C by A? C by A is 2 by 10, which is 0.2, right? So 2 by 10 is 0.2. So A is 10, C is 2, B is 1.5, and D is, I forgot, D is 4, right? So yeah. So CB by A minus D is minus 3.7, and 1 by A is going to be 0.1, and D is, and B by A is going to be, correct? Which means you are going to get answer D, right? 0.2 minus 3.7. Sorry, 0.2 minus 3.7, 0.1. Yeah, answer B. Is this fine? So what did we do? We wrote what we know and we wrote what we want. Correct? This is what we know and this is what we want. Okay. So basically you have to rearrange the terms knowing what you have to eliminate. Finally, what you want, right? I1 and V2 is a function of V1, I2. So eliminate the other terms. That is the point. So basically you are just rearranging the terms, you get the answer. Is this fine?
Yes, sir.
Okay. So then we will go ahead with the next question. Yeah, so determine the y parameter of a two-port network whose z parameters are as given. So, you know, z and y are directly complementary. So y matrix would be directly z matrix, the whole inverse. That is, you take an inverse of this matrix, you get the answer. Okay. So I'm not doing this. We will do other problems. Okay. This is a very simple, right? So y is equal to z inverse. So the answer turns out to be D. Oh. Okay. The answer is D. That is, you have Z. So first of all, you find out the determinant of Z. So determinant of Z turns out to be what? AD minus BC. That is 10 into 10, 100 minus 50, which is 50, right? And what is inverse? Inverse of any matrix, right? That is going to be 1 by delta into adjoint of A, right? That is 1 by 50 into what is the adjoint matrix? You basically invert your A and D positions and you kind of negate your B and C positions. Correct? That is your adjoint matrix. So 10 by 50 is 0.2 and minus 5 by 50 is minus 0.1. So And again, this is going to be minus 0.2 and 10 by 50 is 0.2. Yeah, so correct. It is option D. Is this fine? So directly we have written the answer. Yeah, this is also simple only.
Yes, sir. It is. Okay, sir.
Okay. So then we will go ahead to the next problem. So the problem is evaluate V2 by Vs in the circuit. Okay. So again, you can see that there's a two-port network. They have given the Z parameters, Z11, Z12, Z21 and Z22. Okay. So you have a source Vs in series with 10 ohms, correct? You have a source Vs in series with 10 ohms and the load is 40 ohms. They have also given the direction for I1 and I2. Okay. Yeah. And one thing to note is that, see, what you see over here, the output of two-port network is not directly grounded. It is connected to ground through a common 4 ohms resistor. So this 4 ohms resistor should not be forgotten. Okay. And the question is find V2 by Vs. That is the voltage ratio, right? What is the voltage ratio? Okay. So first of all, we know just one thing is that, see, you cannot directly write V1 is equal to Z11, I1, Z12, I2 and so on. Because why? Because you know that it is not directly grounded, correct? Okay. So let's call this as, let me call this particular node as Vx. Okay. Let me call this as Vx. So then you know that by KCL, right? By KCL, whatever current is entering inside has to come out, correct? So this current is also I1, right? And similarly, I2 is entering inside. So the current that comes out over here is also I2. So what you see is that both of these currents are going to get added up, right? So this I1 is coming here, I2 is coming here. So the current that flows over here is going to be I1 plus I2. Okay. So what I can write is that Vx is equal to 4 times I1 plus I2. Okay. So we have written the expression for Vx. Okay. Fine. Okay. So now that we know what is Vx, we can write what is Vs as well. Vs is what? Vs is 10 I1, just apply KVL, right? So 10 I1, right? Plus V1 plus Vx. Okay.
Sir, I guess this will be minus B1.
Why would it be minus V1?
We are traversing from the positive end to the negative end. So voltage drop will be negative, sir. If you are using KVL, sir, and you are
See,
taking
I have
loop.
written, yeah. So I have written Vs is equal to, not, I'm not writing Vs minus 10 I1. See, I1 is traveling like this, correct? I1 is traveling like this.
Okay, okay,
So,
sir. Okay. Okay, got it, sir. Got it. I actually thought that you were writing the KVL equation and then equating, sir. Got it, sir.
no, I directly wrote equal to.
Okay,
Okay,
okay, okay.
so what you see is that Vs, so what you see is that Vs is equal to 10 I1, right? Plus Yeah, okay. So there is a change over here. So eraser, yeah. Yeah. So Vs is equal to 10I1 plus Vx, correct? And we have to write what is the voltage across your two-port network, right? This particular voltage. So let's call this VA and let's call this VB, right? Because V1, what they have defined as V1 is across the total thing, that is your two-port network as well as this, right? So we have to just write what is your VA, okay? So now you know that for a two-port network, or if you want to write the Z parameters, so if you have VA and VB, that would be Z11, Z12, Z21, Z22 multiplied by I1, I2. Is this fine? For this particular Z parameter network, you cannot write V1 and V2 because you see V1 is actually including the 4 ohm resistor drop, right? So you cannot directly write it. So what I can write is Vs is equal to 10I1 plus Vx plus Va. Is this fine?
Yes, sir.
And where your VA is basically, VA is basically Z11 I1 plus Z12 I2, right? That is, they have given what is the Z11, Z12 and all. So you have 12 I1 plus 8 I2, right? And likewise, you have VB is equal to Z21 I1 plus Z22 I2, which is going to be 8 I1 plus 20 I2. By the way, it's a reciprocal network, right? Because Z12 equal to Z21. Okay. So this is how you get what is Vs, right? So um, likewise, you can also write what is going to be your V2, right? V2 over here, right? So V2, you can observe that V2 is going to be minus 40 I2, right? Because I2 is flowing like this from bottom to top, correct? So the drop would be something like this. So that's why I have written minus 40 I2. V2 is equal to minus 40 I2, right? So V2 is minus 40 I2. So, or I can also write it as VB plus Vx, correct? Okay. Till this point, is it fine?
Yes, sir. It is okay, sir.
Okay. Okay. So you know what is VB, you know what is Vx, and you know V2 is equal to minus 40 I2. So let's try to get a relation between I1 and I2, right? That would be the first step, right? So V2 is basically minus 40 I2 is equal to VB plus Vx, right? So minus 40 I2 is equal to VB is 8 I1 plus 20 I2 and Vx is 4 I1 plus 4 I2. Okay. So minus 40 I2 is equal to 8 plus 4, 12, 12 I1 plus 24 I2. Okay. So minus 64 I2 is equal to 12y1. So what you get is basically I1 is equal to minus 12 by 64 I2, or 4 would be 3 times over here and 16 times over here. So yeah, is this fine? So you have got a relationship between I1 and I2. Okay. So first we wrote KVL equations and then we use the parameters, Z parameters, and we try to put both of them together. Okay. So you have got a relation between I1 and I2. So once you get what is the relation between I1 and I2, the answer is very simple. So let's take a new slide.
Sir, can you just wait for a minute, sir?
Yeah,
Last
sure. Are you understanding till this? But
Yes, sir. Yes, sir. Yes, sir. Okay.
okay.
Okay, sir. We can proceed now, sir.
Sure. Okay. So we have now got a relationship between I1 and I2. So let's go ahead and directly find out what is V2 by Vs. Okay. So V2 by Vs is what? V2 is basically minus 40 I2 and Vs is 10 I1 plus Vx plus Va, right? 10 I1 plus Vx plus Va. So let's simplify Vs first. So Vs is equal to 10 I1 plus Vx plus Va, correct? Yeah. That is 10 I1 plus Vx is 4 I1 plus 4 I2 plus Va is 12 I1 plus 8 I2. 12 I1 plus 8 I2. So group all I1 terms together. So 14 plus 12 is going to be 26 I1 plus 12 I2. Correct. So you know that I1 is minus 3 by 16. Correct. So 26 into minus 3 by 16 I2 plus 12 I2. Correct. So let's simplify this. You get 26 into 3. 16. So we get minus 4.875 I2 plus 12 I2, which is going to be minus 7.125 I2. Okay. So you get minus
Sir,
7.
plus 7.
Oh, sorry. Plus 7.125 I2. Okay. So yeah, somewhere around 5.6. Okay. Do you understand the procedure? What 5? Okay. So apparently there is a mismatch. Maybe done some calculation mistake there. Just a second, I'm just checking. Yeah, so it is 0.316. So somewhere probably we have done some calculation mistake. Mhm. Just give me a second. I'm still doing this. Mhm. Oh, so this white is going inside. So here also I guess side is going inside. Okay, so this is fine. Um, okay, so 12 by 64 minus 3 by 16. Okay. So V2 by Vs is what they ask. So Vs is 10I1 plus Vx plus Va, correct? So 10I1 plus Vx, okay. Va is 12I1 and 8I2. So 10 plus 14, 14, 26. And 8 and 4 is 12. Okay, so 26 simple. I1 is minus 3 by 16. Minus 3 by 16. Okay. So this gives us minus 4.875.
Sir,
Huh?
when you have written the expression Vs is equal to 10 I1 plus Vx plus Va, actually
Hmm?
in that look there are four voltages, sir. There is also V1 there, sir.
No, V1 is just a summation of VA and VX, right?
Okay. Okay.
So V1 is not an independent voltage source.
Okay, sir.
Hmm.
No, we can write that expression as Vs is equal to minus 10 I1 plus V1
Vx is equal to minus.
minus 10 I1
Hmm.
minus V1, or you can write Vs is equal to 10 I1 plus V1. In place of Vx and Va, we can directly
You
write
can write,
Va.
but anyway, you have to define what is V1, right? So how would you know
Yes.
what is V1? V1 is equal to VA plus VX finally. Correct.
Okay. Okay, sir.
I think we have done some calculation mistake only because the step is actually correct that we have followed. So I'm just taking the answer key. So mhm. Yeah, so we have also written Vx is equal to 4 into I1 plus I2. Okay, so the equations are there, and the output relation is Vx plus V2 is equal to, sorry, Vx plus Vb is equal to minus 40 I2. Correct. So it's 20. So I1 is equal to minus 16. Oh God, we have made a very silly mistake. Yeah. So so you rearrange this equation, right? I1 is equal to, sorry, I will take a new pen. What is I1? I1 is equal to minus 64 by 12 I2. Correct? We have written the inverse. Hello?
Yes, sir. Yes, sir. Got it, sir.
Yeah, so we have made a very silly mistake. Hmm. Yeah. Okay, so I1 is equal to minus 16 by 3 I2. Okay. So that is the only thing that we need to substitute over here. So again, this would be incorrect. So what is Vs? Vs is equal to 26 I1 plus 12 I2, which is 26 into I1 is minus 16 by 3 I2 plus 12 by. Okay. So this kind of gives me 26 into 16 by 3. So minus 1. So it gives me minus 126.66 minus 126.67 I2. Correct? So you get V2 by Vs is equal to minus 40 I2 divided by minus 126.67 I2, right? So 40 divided by answer. Yeah, so it is perfectly matching. It is 0.3158. Is this fine?
Yes, sir. Got it, sir.
Okay, yeah, just a small mistake, and yeah. Okay, so fine. So if this is fine, we will move ahead with the next problem, right? Yeah, so again, the question is to find the transmission line parameters, that is your ABCD parameters for the circuit. Okay. So if you want to present this network as an ABCD network, right? That is what you will do is you have a 6 ohm, you have a 6 ohm resistor over here. So you have V1, correct? And okay. V2 over here. So you have I1 going in this way, and you have minus I2 going outside, so or I2 going inside. So you have I2 going inside. Okay. So the idea is to find out the ABCD parameters, or basically, ABCD parameters basically V1, I1 is equal to A, B, C, D, V2 and minus I2. Okay. So we have to find a relation between your input and output side. Okay. That's it. If we do that, then the answer is done. Okay. Okay. So now the point is, the next thing is, what is A, right? What is A? A is basically V1 by V2 with minus I2 equal to 0, correct? Right? That is, your output side is left open. So your output side is left open. Okay. So if your output side is left open, so let me, yeah. So if your output side is left open, right, then what would the circuit become if your output is left open? Output is left open. In that case, your circuit becomes 6 ohms, 1 ohm. This is your V1. Okay. It has 6 ohm, 1 ohm, and then 12 ohm. This is your 2 ohm. Now the output is left open. Okay. So V2, so there is no current I2. So I2 is 0. Okay. So if your I2 is 0, it means that there is no drop across your 4 ohm resistor, correct? So across your 4 ohm resistor, there is no drop. Why there is no drop? Because I2 is 0. There is no drop. Therefore, you can tell that V2 is basically the voltage across your 2 ohm resistor directly. Correct? Is this fine? Conceptually, I2 is 0. There is no drop across your 4 ohm resistor. Therefore, V2 is the voltage across the 2 ohm resistor. Okay? Is this fine till this point?
Yes, sir.
Oh. But unfortunately, we don't know what is V1. So therefore, we cannot directly assign or solve it using some numerical with numerical numbers. Instead, what we are going to do is okay. So instead of that, what you can do is you can solve either by using KCL, either by using nodal analysis or by using this mesh analysis. Okay. So if I call this as Vx again, then what you can do is Vx minus V1 by 6 plus Vx by 1 plus Vx minus V2 divided by 12 is equal to 0. This is 1, and you of course know that V2 is the drop across your 2 ohm resistor, correct? So what you can do is if you solve by mesh analysis, so you take a current, let's say IA, and this will be IB. For solve for what is IA IB, right? So V1 would be 6 IA plus IA minus IB, that is 7 IA minus IB, and your V2 is basically going to be directly 2 IB, right? Right? Is this fine? So no need to write analysis. Is this fine? I have just
Yes.
applied mesh
Yes, sir.
analysis. Okay, so we have written what is V1 and V2. We know V2 is equal to 2 IB. Okay, so which means that um, IB is equal to V2 by 2. Okay, so put that back in V1. So V1 is equal to what? V1 is equal to 7 IA minus V2 by 2. Okay. Okay. So this is one expression. Okay. Now the point is we have to eliminate what is IA, right? So we have to eliminate IA. So what is IA? Let's go to the next page. So let's go to the next page. So what is IA? So just where so if this is your Vx, correct? So what would be your IA? So IA is going to be V1 minus Vx by 6. Correct? That is your IA. So V1 minus Vx by 6 is IA. Okay. And what is Vx? Vx is equal to voltage drop across your 1 ohm resistor, which is going to be 1 into IA minus IB. Vx is equal to IA minus IB. Okay. So V1 minus Vx is IA minus IB. Correct. Equal to 6 IA. V1 minus IB is equal to 6 IA. Okay. Just a second. What else can we do? Okay, so yeah, so um the point is over here we don't know the values for V1 or V2, right? So that is why we cannot directly solve by this method. What we can do is okay. So what we can do is we can break this entire network. Okay, so I'm doing by a different method now. So what I will do is we will break this entire network then. I think that will be fine. So 6 ohm and 1 ohm and 12 ohm, 2 ohm and then 4 ohm. Okay. So now what we'll do is we'll break this entire network. Okay. So this is a series element, right? Series element and it's an impedance. So I can write that this particular element can be represented as 1 Z 0 1, right? It's a series impedance, which means this can be written as 1601. Okay. And after that, I am having an element in shunt. Okay. A shunt path element can be written as what? It can be written as 1 0 y 1, right? That is 1 0 admittances 1 by 1 and then
1. Okay. Likewise, I will write for this 12 ohm, it can be written as 1, 12, 0, 1. So this can be written as 1, 0, 1 by 2, and then 1. So this can be written as 1, 4, 0, 1. Now all of these elements are in cascade, right? Therefore, your transmission line parameters A, B, C, D can be written as multiplication of all of these. That is 1, 6, 0, 1 multiplied by 1, 0, 1, 1 multiplied by 1, 12, 0, 1 multiplied by 1, 0.51 multiplied by 1401. Okay. It's just a 2 cross 2 matrix multiplication, which means it shouldn't be that difficult. Okay. So what you would end up is M1 into M2. So 1 plus 6 would be 7 and 1 plus 6, 0 plus 6, 6. Right. 0 and 1 is 1 and this also 1. Okay. And then you get the rest of the elements. So let me take a new slide. Yeah. So basically you are multiplying, right? That is 7, 6, 1, 1. Then you had 1, 12, 0, 1. Then 1, 0.51 and 1, 4, 0, 1. Correct. So you just multiply. So again 7 and you have 7 12s are 84 plus 6 90, then 1 and then 12. Sorry, 1 and then 13. Okay, so how much do you get? You get 7 and 19 to 0.5 is 45. So 45 plus 7 is going to give you 52. And 90. So let's use 7.5 and 13. So this gives you 52. 52 into 4 plus 9. How much? 298. Then 7.5 and then 7.5 into 4 is 30 plus 13 would be 43. So yeah. Correct. 52, 298, 7.5, 43. Yeah. And of course, unit would be how much? It's ABCD parameters. So V1, I2 is equal to ABCD I1, sorry, V2, I2. So V1, I1 is equal to V2, I2. So V1 by V2 and V1 by I2, it's going to be ohms and 7.5 Siemens. And again, it's dimensions. Is this fine? So better, yeah. So the better option would be to actually break this entire thing up into individual impedances. So write the matrices for the individual impedances. Okay. So series branch would be 1Z01 and shunt branch would be 10Y1. So if it is series, it's going to be 1Z01, and if it's shunt, it's going to be 10Y1 admittance. Okay. Is this fine? I think, yeah, this is the best way to
Yes, sir.
find out the transmission parameters. Okay. 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 So if this is fine, we will move ahead to the next question. Right. Again, very similar problem. So we have to break this down into matrices. Okay. So how do we write? So this would be 1, 10, 0, 1. Okay. This would be 1, 0, 1 by 20, 1. It's 1 by 20, not directly 20. Okay. Admittance. Similarly, this would be 1, 30, 0, 1. This would be 1, 0, 1 by 50, 1. And so on. 1, 40, 0, 1. This would be 1, 0, 1 by 20, 1. This would be 160, 0, 1. Okay, just a multiplication, right? So you have to multiply each and everything. So what I'm doing is I'm just writing the multiplication for first two matrices. So the multiplication for first two matrices is okay, 1, comma 2, right? First multiplication will be how much? So 110, 0, 1 and 1, 0 minus 1 by 21, right? 1 plus 10 by 20, correct?
To
One.
next. To next.
Sorry?
Sir, move to next step.
Yeah. I was just searching for my calculator, no worries. So 1
Yes.
plus 10 by 20 and 1, and then this is 10, and this is going to be 1 by 20, 0.05, correct, and 1. So this is 1 and 2. So if I want to multiply this with 3, right? So 1, 30, 0, 1. So 1, 2, 3 would be how much? This would be 1.5, and then 1.5 into 30. So it would be 45 plus 10, 55. And then it would be 0.05 and 30 into 15 and 1.5. Sorry, 1.5 plus 1 would be 2.5. Okay, and I will multiply with this 4. 1, 0, 1 by 50 would be 0.021. Okay, so what you're going to get is 1.5. Okay, I need calculator definitely. 1.5 plus 55 into 0.02, you get 2.6. And then 55, 0.5. And 2.5. So come on, 5, right? So 140, 0, 1. So you're going to get 2.6. 1 into 40. 104 plus 55. 159. This is going to be 0.1. 0.1 is 4 plus 2.5. 6.5. Correct. I will do 6 multiply with 6. 1 0 1 by 20 0.05. 0.6 plus 2 0.05. 10.55. 59. Right. And 0.1. 0.425. Correct. And 6.5. So multiply this finally with 7. Correct. 160, 0, 1. So you get 10.55 and 10.55 into 60 plus 159, you get 792 and 0.425 and into 60. 6.5, you get 32. Yeah. So this is the answer that you get after multiplying everything. Is it matching? Yeah, 10.55, 792 ohms, 0.425 Siemens, and 32. Yeah, option D. Is this fine? Hello?
Yes, sir.
Okay. Yeah. So again, this is just multiplication. Note that if it's a series element, it has to be 1 Z 0 1, and if it's shunt element, it has to be 1 0 Y 1, where if they give the resistance, you should know that Y is basically 1 by Z. So don't directly substitute the resistance. Okay. Okay. So we will go ahead to the next question. Yeah. Okay. So
Single element.
hello.
नहीं सर क्वेश्चन रीड कर रहे थे सॉरी.
Okay. Okay. No worries. So for the single element two port network in figure, H21 is dash. Okay. How do you solve this? What is H parameter? How do you define the H parameter? So we saw earlier also that is V1 I2, correct? H parameter is V1 I2 is equal to H into I1 V2. Okay. V1 I2 is equal to H into I1 V2. So we will make use of this. So yeah. So V1 I2 is equal to H11, H12, H21, H22 into I1 V2. Correct? This is the H parameter. So the question is H21, right? What is H21? From this itself, you can write that H21 is equal to, what is H21? H21 is equal to I2 by I1 with V2 equal to 0. Correct? Hello, is this correct?
Yes, sir.
Okay, sorry. So, yeah.
Sir,
So the
sir,
point
is
is,
it, sir, is it I2 I1 V2 is equal to 0 or V1 is equal to 0, sir?
see, in the output, with what are your independent variables? So these are your dependent variables, correct? V1 and I2, and your independent variables are I1 and V2. So you remember superposition theorem. What did we do for superposition theorem? Disable. So let's say there are two independent sources in the circuit, right? So let's say I have 40 volts one source and 20 volts is the other source. What I will do, I will first see the effect of 40 volt source disabling the 20 volt source and vice versa, correct? So same way here also I am having two independent variables. Disable the independent sources one at a time. Correct? So when I see the effect of I1, if you want to see I1, then what you will do is disable V2. And if you want to see the effect of V2, you will disable I1. Okay. So if you want to disable voltage source, you will, what will you do? You will
Short circuit, sir. Sorry, open circuit, sir. Open circuit. Well, I2 have to short circuit.
correct. Okay. Fine. So put V2 is equal to 0. Okay. So we have put V2 equal to 0. Now in this network, let us mark what is I1 and I2. So by definition, we know that I1 goes like this and I2 goes like this. So from this, can you write what is the relation between I1 and I2? I1 is equal to minus I2. So I2 by I1 would be what? Minus 1. Okay.
Minus
Don't
1,
get,
sir.
yeah, so don't get influenced by this resistor. Don't think it is 1 by 10 or 10 or something. See, it is direct. You just need to know H parameter definition. You see I2 by I1 over here, it's directly connected. And based on the convention that we follow, I1 and I2 are in opposite direction. So you get I2 by I1 equal to minus 1 directly. Okay.
Yeah, sir. Say.
Okay. Okay. So the next question is, when port 1 of a 2-port circuit is short circuited. Okay, so port 1 is short circuited. I1 is equal to 4 I2 and V2 is equal to 0.25 I2. Which of the following is true?
दोनों में से कौन सा?
Sorry?
सर क्वेश्चन रीड कर सर.
Oh, okay. No worries. Okay. So when port 1 is short circuited, that is Port 1, okay. So port 1 is short circuited. I1 is equal to 4 I2 and V2 is equal to 0.25 I2. Okay. So which of the following is true? Right. Okay. Okay. So if port 1 is short circuited, right? So if port 1 is short circuited, you know that. So we go back to the basic definition of a two-port network, correct? So yeah. So port 1 is short circuited. In this figure, port 1 is short circuited. It means that V1 is equal to 0, right? If port 1 is short circuited, V1 is equal to 0, correct? Correct. And we are talking about Y parameters. Sorry. So V1 is short. So port 1 is short circuited, which means that V1 is equal to 0, right? It's a short. So V1 is equal to 0. Okay. So we go back to your Y parameters because the question is on Y parameters. So in this particular set of equations, you just put V1 is equal to 0. So the equation is going to reduce, right? Okay. So we will go ahead and solve it. So what you have is I1, I2 is equal to Y11, Y12, Y21, Y22, V1, V2, correct? So port 1 is short circuited, it means that V1 is basically 0, right? So you can write I1 is equal to Y11 V1 0, I1 is equal to Y12 V2, okay? And you also write that I2 is equal to Y22 V2, right? Okay. Now the point is they have given I1 is equal to 4 I2 and V2 is equal to 0.25 I2. Okay. So you can kind of relate these two expressions, right? So what you get is basically rearranging this expression, you get I2 is equal to 1 by 0.25 is 4 V2, correct? I2 is equal to 4 V2. So therefore you know that Y22 is equal to 4. Okay. Y22 is equal to 4. So here it's Y22 is equal to 0.25. Therefore this is wrong. The question is which is correct. Okay. Okay. So this is wrong. Then the next question, the next part is I1 is equal to 4 I2. Okay. Again, so I1 is equal to 4 I2 is given. So 4 into I2 is basically I2 is 4 V2. So 16 V2. Okay. So what you see is that I1 is equal to Y12 V2, right? So Y12 is 16. So this is correct. So Y12 is equal to 16 is correct. Okay.
Yes, sir.
So from the given data, you cannot conclude about Y11 and Y21 because port 1 is short circuited, so you don't know anything about it. So no need to comment on that, but apparently itself it is visible over here. Y12 is 16 is correct and Y22 is equal to 0.25 is incorrect. Okay, just rearranging the terms, you know the definition for y parameters, you get the answer. Okay. Okay, so we'll move to the next question. Right. A two-port network is a two-port network is described by the
Describe
following
as
equations. V1 is equal to 50 I1 plus 10 I2. V2 is equal to 30 I1 plus 20 I2. So what parameter is given over here? V1, V2 as a function of I1, I2. So this is basically V1, V2 is a function of I1, I2. So basically Z parameters. Correct?
गेट पैरामीटर ठीक है सर
Okay. So from this itself you can write Z11 is 50, right? Z21 is 30. Z12 is 10 and Z22 is 20. Okay. So which of the following is not true? Z12 is 10. So this is correct. Okay. And the remaining are from other parameters. So we have to find out the others as well. So once you know what is Z parameters, obviously you know what is Y, because Y is basically Z inverse. So let's find out what are the Y parameters. So Y is basically Z inverse. Therefore, 1 by mod Z into adjoint of Z. Correct? So 50 into 20 minus 300. So that will be 1 by 700. Adjoint of Z means the diagonal elements will exchange and these two will get negative sign. So what you get is Y12 is basically minus 10 by 700 or minus 1 by 7. Correct? Sorry, minus 1 by 70. You get minus 0.143. 0.0143. Yeah, so this is also correct. Okay. So
yes
the
sir
Z
option
is correct.
sir B option is correct
So this is also correct. Okay. Okay. So
yes
next point is we have to go to the H parameters, right? So what is the definition of an H parameter? So, so this was one, that is Z parameter. Then we came to Y parameter. Now we are going to the Z parameter, H parameter. So for H parameter, V1 I2 is equal to H parameter H11, H12, H21, H22 into I1 V2. Correct?
yes sir
Okay, so now I want only H12. Okay, so what is H12? What is the expression for H12? So V1 is equal to H11 I1 plus H12 V2. Okay. Okay, so I want V1 in terms of I1 and V2, but what I have is I have V1 in terms of I1 I2, right? I have V1 in terms of I1 I2. I want to have V1 in terms of I1 and V2. Okay, so we have to eliminate I2 term in this expression, I2 term in the given expression. So given is V1 is equal to 50 I1 plus 10 I2. So eliminate I2. So eliminate I2, you will get the answer. You will get V1 in terms of I1 and V2. Okay. Okay. You understand, right? Like what step we are following. So V2 is 30 I1 plus 20 I2. Okay. So basically I want to remove I2. So what I will do is I2 is equal to what? I2 is equal to V2 minus 30 I1 by 20, right? So I will go ahead and substitute this over here. Okay. So this is 50 I1 plus 10 I2, right? So 10 by 20 into V2 minus 30 I1. Correct? So
Yes, sir.
10 into 30 by 20 is 15. So 50 minus 15. 35 I1 plus 0.5 V2. Is this correct? V1 is equal to 35 I1 plus 0.5 V2. So we have brought it in terms of I1 and V2. You see, H12 is basically 0.5. Okay. So this is also correct. Are you understanding the steps? I'm just writing it in a rough manner. I mean, are my steps understandable? Are you able to understand?
Yes, sir.
Okay. Just note this, that what variable you have to eliminate, what variable you have to substitute. Okay. So that thing you have to be clear in your mind. If you're clear, you're done. Okay. That is the trick for two-port networks. Okay. And finally, we will just check for, we obviously know that A is not correct, but we will just check. So I will take a new slide. So we have to find, they have given A parameter, A is equal to 50, right? So what is A? We know that A is basically V1 by V2 with I2 equal to 0, correct? That is V1 I1 is equal to A, B, C, D, V2 minus I2, right? So A is equal to what? V1 by V2 at for minus I2 equal to 0. Okay.
Yes, sir.
V1 by V2 at I2 equal to 0. So in the given equation itself, put I2 equal to 0. So given equation is what? V1 is equal to 50 I1 plus 10 I2 and V2 is equal to 30 I1 plus 20 I2. 30 I1 plus 20 I2. Put I2 equal to 0. So you get 50 I1 is equal to V1 and you get V2 is equal to 30 I1. Okay. So what is V1 by V2? V1 by V2 is basically 50 I1 by 30 I1. You get 5 by 3. Okay. But they have given A is 50. Sorry? Huh.
Yes, sir.
So they have given A is 50. So this is the incorrect one. Is this fine?
Yes, sir.
So see, in this problem we had to do from Z parameter, Y parameter, and then H parameter. That is conversion from Z parameter to H parameter also we have seen. Just note which element you have to eliminate. So these are your dependent variables and these are your independent variables. So you have to see which equation you want, which equation you are having, and suitably eliminate. Okay.
सर इसमें तो 3 को आंसर सर मतलब इसमें सर
हाँ
3 मतलब सही हो गया और एक रॉन्ग हो गया लास्ट वाला
yes. The question is which of the following is not true, right? Which of the following is
Yes,
not
sir.
true? So A is equal to 50 is not true. This is galat. The correct answer is 5 by 3. Okay.
Yes, sir.
Okay. So then in that case, like I think we can conclude for the day. Or shall we do one more problem?
Sir, one more, sir, about that 2 ohm, 8 ohm, 12 ohm, and 4 ohm problem, sir. Yes, this one, sir.
Oh, you got this question already?
Actually, sir, I downloaded the solutions with the solution that was uploaded to the NPTEL website, sir.
Okay, okay.
We
Nice,
got it from
okay.
there, sir. But the methods of solution in that case are different from what you are doing, sir.
Ah, okay. It can
But this
change.
is actually conceptual, sir. Because if you know all the concepts, you can do it in your own way, sir. No need to mug
Yeah,
up that.
sure. No, please do not mug up. You just know that okay, hybrid means V1 I2 relates to I1 V2. That much you should know. Only that much you should know. Don't mug up.
Yes,
Okay,
yes, sir.
how to convert ABCD to Z? Z11 is equal to B by A, D by A. Don't mug up those things. Waste of
Yes,
time.
sir. Sir, actually, if you mug up in two-port networks, you will definitely mess up in the examination.
Yes, definitely you will forget. Yeah.
Yes, sir.
Okay. So okay, so they have asked for the Z parameters, correct? So again, we go back to basic definition of Z parameter. You have V1, V2 that's getting related to Z11, Z12, Z21, Z22, and then I1, I2, correct? Okay. So you know that in this equation or in this ladder, you have this is V1, this is your V2, correct? And something like this. Okay. So now the point is, let me call this midpoint as Vx. Okay. We will call this midpoint as Vx. Okay. Okay.
यस सर. इस पॉइंट पे सर मतलब क्या बोलते हैं कितने वोल्टेज हैं Vx पॉइंट पे, यही फाइंड करना है.
We have to find it as an expression of we have to find it in terms of I1 and I2 because no magnitude is given, only the network is given. Correct? So we will use Vx and later on we can eliminate it. Okay. Okay. So, or what I will do is now I will erase this. I will draw the ladder. So you have 2 ohm, V1, V2, I1, I2. This is Vx. Okay. Okay. So now the point is, what is I1? I1 can be written as V1 minus Vx divided by 2. Correct? I2 can be written as, see, this is V2, right? This is V2. So I2 can be written as this current plus this current. Okay. So V2 minus Vx by 8 plus V2 by 4. Okay. That is what you get is basically I2 is equal to 3V2 by 8 minus Vx by 4. Okay. This is your I2. 3V2 by 8 minus Vx by 4. And finally, you have by nodal analysis at this node. Correct? Nodal analysis, you get Vx minus V1 by 2 plus Vx by 12 plus Vx minus V2 by 8 is equal to 0. Correct? Okay. So you see that this is basically yeah, so this is basically a 3-variable system, right? That is, you have V1, V2, and Vx. So we just need to solve over here. Okay, you solve it and you get the expressions for V1 and V2 in terms of I1 and I2. Okay, just we need to solve this. All right. So this is from nodal analysis. Okay, so again V1 minus Vx divided by 2 is equal to I1. Then V2 minus Vx by 3V2 by 8 minus Vx by 4. V2 by 8 minus Vx by 4 is equal to I2, and Vx minus V1 by 2, which is basically Vx minus V1 by 2 is I1. So I1 plus Vx by 12 plus Vx minus V2 by 8 is equal to 0. Okay. So again, let us eliminate what is Vx, because we don't want Vx. So this expression, or any expression also. So in this expression, what is Vx? Vx is basically 2I1 minus 2I1 plus V1 is Vx. Okay. And in this expression, Vx is basically I2 plus, or sorry, I2 minus 3V2 by 8 into 4. Okay. Yeah, so this is your Vx. Okay, so substitute your Vx over here. So I1 plus Vx by 12, right? So 1 by 3 into minus I2 plus 3V2 by 8 plus 8 into Vx of 8 is 1 by 2 into minus I2 plus 3V2 by 8 minus V2 by 8 equal to 0. Okay, so now in this expression we are having only V2, I1 and I2, right? So we can just simplify this, and so in the interest of time I am not doing, okay, but you understand, right? You just need to simplify this expression. You get what is V2 as a function of I1 and I2. Okay, similarly in the above expression also you can get function of V1 as function of I1 and I2. From that you get what is the self parameter. Is this fine? Like, hello?
Sir, a little bit doubt in the third expression, sir. From nodal
Yeah.
analysis, actually, we got that Vx minus V1 by 2. So how it
Correct.
become I1, sir? Must be I minus I1.
Oh, sorry, it must be minus I1. Okay. Yeah, it must be minus I1. Correct. Yeah. Yeah. You're right. Yeah, but is it fine? I think the steps are fine, right? Okay.
Sir, next place. Next place, please, sir. 1 minute, sir.
Yeah. You solve it, please. You go ahead and solve this. This is just simple expression only. Solve it.
Yes, sir. Okay, sir.
Okay. Okay, so we will break for the day. Still, we have 3 questions left over here. I mean, these are simple only. If we have time, we will cover these in the next class on Tuesday. Okay.
Yes, sir. Yes, sir. Please.
Okay. Okay. So yeah. Thanks for attending and goodbye. Have a great weekend.
Thank you, sir. Same to you.
Okay.
Thank you, sir. क्या हाल है दोस्त फ्रेंड Oh my God. आवाज is not clear. कैसे दोस्त ठीक है अपने अपने थोड़ा इंट्रोड्यूस करो और कुछ बढ़िया बताओ कैसे क्या करने वाले हो कुछ tell me what do you yes no yes no yes no yes yes you yes अब देखो क्या होता है ट्यूसडे बोला ट्यूसडे को ये